Okay, this is a logistic regression. So let's think about the one case. It's a spam email detection system. So actually these days, either the email server or the client program actually detecting some spam email and then put it to the like a junk email folder. Sometimes it's an important email fall in the junk email or spam email folder, so you have to find out. But most of case, this spam detecting system is working pretty well. Yeah, they cannot detect all the spams, but uh, a lot of them can be filtered by this spam detection system. Okay, so how can we find out? I mean, yeah, as a human, we can read and then we can find out this is the spam or not. But can we make some kind of the software they can detect if this is a spam or this is not a spam email? These days, AI neural network is so amazing, so maybe they can do the better. But we will talk about the like a statistical model here. Um, so okay, so Peter worked as a cybersecurity analyst in some company, and his colleague at the firm has been overwhelmed by the large-scale spam email. Peter would like to implement the effective spam detection system. So he wanna find out is a spam or not. So he analyzed a sample of 500 spam and legitimate emails, so spam or not spam email. So there's 500 of them. So we have this data. You can download from our LMS. Either we can check because this is already the human check is a spam or not. So if this is 1 means it's a spam, right? And 0 means it's not spam. Right? And then usually the spam email has a lot of recipients. So how many recipients there will be the use as a detecting factor, and how many hyperlink is included. What is a typical spam email? It's sent to a lot of people. That's why there is a lot of recipient, and trying to this is what we call it phishing, right? Phishing. Trying to lure, bring you into some fake website and then trying to collect some information. So how many hyperlink is included in that email, and then how many characters in there? Uh, so using this one, can we find out is it spam or not? Develop the logistic regression. So we will talk about the logistic regression because this chapter is about logistic regression. And then we will find out how can we measure the performance. So we will talk about a little bit about this performance side, and this performance side, how we find out how to measure the performance is pretty similar. It's not similar, it's exactly the same. And when we have a machine learning, most of the area machine learning working pretty well is the classification. Right? So classification model, um, we use the same performance measure here, so we will talk about it. What is the difference of this spam email detection is so far the response variable or independent variable, the dependent variable, right? Dependent variable y is so far it was a quantitative, right? So our y b0 plus b1 x1 plus, right? This case y is a quantitative. It's a kind of number. So you can have a 1, 2, 3, 4, 5, 6, 7 quantitative. So you can have a big number, small number, the middle number. However, our case, spam or not, is a binary choice. Or most of case, this is what we call the classification. Most famous thing is the we trying to distinguish the is it cat or dog. So if the one picture is given, then can you tell this is a cat or this is a dog? Again, this is the classification model and has a binary response variable. This is a 0 or 1. So example is whether or not to approve a loan, and then this is a kind of some person came to you. Suppose you are a banker. One person came to you and then asking the certain amount of money to borrow, and then you just will figure it out. This guy has enough financial ability to pay back the money. So what is the age? He has a family or not? How many kids there? What kind of car he has? What kind of house he has? And you will collect a lot of information, right? And then if he has a pretty good job, expensive house, and he doesn't have a lot of debt, then he will have the ability to pay back, right? So, however, can we make a system kind of systematic rule? We can tell he will pay back or he will default. Default means he cannot pay back the money. This is also kind of the binary response variable. So either he pay back or he default. Therefore, this case, the regular regression model doesn't work pretty well. So we will see what is the problem, and actually we have this kind of the model using the regular regression. This is what we call the linear probability model. So again, we just bring the linear regression model just like we used so far, and then binary response y is the expected value of the expected value. Okay, so it can be 1 or 0. So what we are trying to calculate is not the 1 or 0, and we want to find out, sometimes it's a 1, sometimes it's 0. So what will be the expected value? So in calculation of expected value, because our value is a 0 or 1, and we have to multiply, expected value will be expected value of y will be 0 times probability that y equals 0 plus 1 times probability y equals 1, right? So therefore this expected value will be just simply the p of y equals 1, and then we call this p is the small p. So when we say the p is that is the probability that y equals 1. Okay, so that's why this is a simple probability here. So what we are trying to calculate it here is we are trying to find out what is the probability of y equals 1. Originally it was the expected value of y. Okay, y was the expected value, but actually that expected value is turned out to be the probability that y equals 1. We call this is a linear probability model, so linear regression, but our independent variable is a probability. That's why we call it a linear probability model. Okay, of course the estimated model is this is estimation. We will find out what is a B0, B1, B2, and so on. The problem of this model is because we just make a prediction, this is a 0 and 1, the curve, the line can be go outside, above 1 or below the 0. Okay, this is a financial information. The Great Recession has forced the financial institute to have extra stringent and guaranteeing the mortgage loan. So when they approve the mortgage loans, 30% of mortgage applications are obtained. So yeah, 30% mortgage, and then you can find out why is what. Why is approved and or not approved. So 1 means if mortgage loan is approved, and then 0 otherwise. Okay, so approval depends on the percentage of down payment. So this is the percentage of down payment, and then percentage of income to loan ratio. So what is the income, and then how much debt he has. So we trying to estimate what is the probability of y equals 1. So basically it's the same as the expected value of y equals b0 plus b1 x1 plus b2 x2. Okay, so predict the loan approval probability for application with a 20% down payment and 30% income to the loan ratio. So you can simply find out what if the probability of the loan approval, right? When x1 is 20 and x2 is 30. What is the p? Once we find out b0, b1, and b2, then we just plug into this number here. Then we can find out the expected value, and then expected value is the probability. So we can tell what is the probability. Later, I will show you the actually this chart, and then because our y value is always 0 or 1, so our dot is located in something like this. So